This time we have a square root. So keep in the back of your head, we have a root. We're probably going to end up having to think about restricting domain or range. So let's go ahead and take a look at our function and decide if it is going to have an inverse that's also a function. I'm going to just show only my original function right now. Notice that our y values don't go past 0. All right. Anytime that you plot a square root function, we talked about this earlier in the chapter, it looks kind of like a half sideways parabola. It's not, because it hasn't been translated up or down, it never crosses the x-axis. So let's go ahead. It looks like I can plot a point at 3, 0, and I can also plot a point at 7, 4. At 3, 0, and then at 7, 4. And my graph is a curve, so it's going to look something like that. All right, horizontal line test time. Take your pencil or pen and run it up and down this. Is there any place where you cross more than once? And the answer is no. So that means it passes the horizontal line test and the inverse is a function. All right, let's go ahead and find the actual inverse. Step 1, change to y. Step 2, switch x and y. Step 3, solve. So we're going to solve for our new y value. First thing I want to do is get rid of the 2 that's out in front because I want to isolate the root so that I can square it. So these 2's will cancel, leaving me with x over 2 is equal to the square root of y minus 3. And then in order to get rid of a square root, I need to square, and that'll happen to both sides. So be careful on doing this left side. Make sure that you take the squared and square both the numerator and denominator. So we're going to get x squared over 4 because 2 raised to the second power, or squared, is 4. And then we'll be left with, this cancels with that, and we're left with y minus 3. All right, so continue solving. We just need to add 3 to both sides. So plus 3 on both sides. And that leaves us with x squared over 4 plus 3. These cancel, leaving us just y. All right, so let's plot that and use the plot to decide what we might need to do about our domain or range. When I plot this, I see that, I get a parabola because I have an x squared. So I'm going to need to restrict things in order to not have a parabola. So I'm going to go in, and if you go to your ABC keyboard, you can find the bracket there. And I'm going to go in and say that I can't have any x values that are less than 0, because when I do, so I need x greater than 0. So now I have that perfect mirror image reflection, not a double image and only half of it is a perfect mirror image reflection. All right, so we are going to have to actually include that as part of our answer. So step number 4, and again, that's kind of based on peeking at our graph, is that we needed our domain to be greater than or equal to 0. So again, we had to restrict it because it was going to give us that double image that we didn't want. We had 7, 4, so we'll have 4, 7. Nope, that's a little too high. 7 is there. All right, so I will draw my graph. Looks something like that. All right, and there's our inverse. Okay, so we can again write this in our inverse notation, function notation. We can say f inverse of x is equal to x squared over 4 plus 3. And again, part of our answer has to be that x is greater than or equal to 0. Okay, so don't forget that part.